So, we're going to just quickly review the quadratic formula. You may or may not need to write this down. Most of you guys are probably going to remember the quadratic formula, but if you need to, that's fine.
I don't think so. Hello, Rebecca Nurse. I didn't know you were still in my backpack.
So we're going to review, I'm going to throw some different algebra stuff in there to review, but we're going to do one more trig unit. Yeah, that'd be great. We're going to do one more trig unit.
She was like, it said it was Miss Flaming's room, or something like that. Something about Flaming. And she was like, wrong number, I guess.
Okay. So we're going to do one more trig unit, and then we're going to focus on pre-calculus stuff, so algebra type stuff. More algebra 2, just kind of extended. We're going to start with quadratic formula, review it real quick. This is based on a quadratic, so ax squared plus bx plus c equals 0. And to solve that for x, so to solve that for x, remember it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Do we remember that? Yeah? Okay. So, how do you get this from this? Do you guys remember how you derive the quadratic formula? I know you did it in Honors Algebra 2. So, and we did it in Algebra 2. ax squared plus bx plus c equals 0. Other ways to solve quadratics. We can factor quadratic formula. What's the other one? You guys remember? Completing the square. So to complete the square, the first thing you have to have is everything in front of the x squared has to go away. So to get that to go away, since it's multiplied, we would divide. So the first thing you're going to have to do is divide everything by a. This is just showing us where this quadratic formula comes from. We would have x squared plus b over a x plus c over a equals 0 divided by anything is just 0, correct? To complete the square, we need the x's on one side, the constant on the other. So we'd have to subtract c over a to both sides. So we get x squared plus b over a times x, plus we leave a blank because we're going to fill that blank in. And we have negative c over a plus, if we add something here, we have to add something here. Do you agree? Now, how do you create a perfect square trinomial? Do you remember? You take half of that middle term and square it. So the middle term was b over a. We take half of that, so we'd multiply by 1/2. So that means it'd be b over 2a, but we square it, right? Which means we're adding b squared over 4a to each side, essentially. A squared. B squared over 4a squared to each side. Does that make sense? Because b squared and 2a squared would be 4a squared. All right, so then you can factor it into a binomial. This would be x. This sign tells us it's going to be plus. And this would be b over 2a. The whole thing squared equals. Now on the right-hand side, we'd have to have common denominators. This is just a, and this is 4a squared. So to get this to be 4a squared, I'd have to multiply by 4a. Correct? So I would have what? Negative 4ac plus b squared all over 4a squared. How do we get rid of something squared? Take the square root. And remember, when you take the square root, you have to have what? Plus or minus. So we now have x plus b over 2a equals plus or minus the square root of, is it fair for me to say this is b squared minus 4ac instead of negative 4ac plus b squared? And all of this would be over, what's the square root of 4? 2. And what's the square root of a squared? A. Here we'd subtract b over 2a. You notice we have common denominators there, right? So we get x equals, I'm going to say negative b plus or minus the square root of b squared minus 4ac all over 2a. That's where the quadratic formula comes from. Do you have to do that every time? No. Do you have to memorize this? Yes. Questions? All right. Let's do a couple examples. If we have 3x squared plus 5x plus 1 equals 0. First thing you have to have is you have to have it in this correct form. Ax squared plus bx plus c equals 0. Is it? Yeah. The next thing we need to do is identify a, b, and c so that we can plug it in. So what would a be here?
3.
B would be, and c would be. All right, x equals, we're substituting in negative b, which is 5, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we get negative 5 plus or minus the square root of 25 minus 12 all over 6. Which gives us negative 5 plus or minus the square root of, what would that be, 13? 25 minus 12 is 13, all over 6. Can you reduce that at all? Those would be your answers. You notice you have 2 answers there, don't you? Negative 5 plus the square root of 13 over 6, and negative 5 minus the square root of 13 over 6, yes? How about this one? X squared minus 6x plus 2 equals 0. That one's in the correct form also, isn't it? What would your a be? 1. How about b? Negative 6. And c is 2. So we get x equals negative b, which is negative 6, plus or minus the square root of b, which is negative 6 squared, minus 4 times a times c, all over 2 times a. So a negative and a negative make a positive 6, plus or minus the square root of 36 minus 8, correct? All over 2. Well, 36 minus 8 is what? 20, 8. Is that right? Over 2. 28. Can that be reduced? Square root of 28? Yeah. What perfect square goes into 28? 4 times 7, correct? So we would get 6 plus or minus the square root of 4 is 2 square root of 7 all over 2. Now can we reduce that even further? Yeah, all 3 of those can reduce by 2, can't they? And so our solution would be x equal, or solutions, 6 divided by 2 is 3, plus or minus 2 square root of 7 divided by 2 is just the square root of 7. Questions on that? Good? All right, one last one here. If we have 3x squared plus 5x plus 4 equals 0. Identify A, B, and C. What is your A?
3,
B,
5,
and C.
4.
All right. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we get negative 5 plus or minus the square root of, what, 25 minus 12 times 4 is 48 over 6. So negative 5 plus or minus the square root of, it's going to be negative 23, isn't it? Can you reduce negative 23? Square root of negative 23? What's the square root of negative 1? That imaginary unit I, right? So this is negative 1 times 23, yes? The square root of negative 1 is I, you're correct. So you would get x equals negative 5 plus or minus I square root of 23, oops, not 33, 23. All over 6. And that can't be reduced, so that'd be your answer. Remember, the square root of negative 1 is indeed I. Okay, last thing I just want to talk quickly about is your discriminant. Your discriminant's what's under the radical, the b squared minus 4ac. And what you'll notice with that is if that discriminant was positive, so if b squared minus 4ac is greater than 0, we had 2 real solutions, right? These are real solutions, these are real solutions, yes? So you have 2 real solutions, or zeros. That's where that crosses the x-axis, yes? The parabola, the quadratic. Okay, if b squared minus 4ac is less than 0, you have 2 imaginary or complex solutions. So that means that that parabola would never cross the x-axis, right? There's only one other scenario, and that's when it equals 0. And think about it. If you had 0 under this radical, you would have just had negative 5, 6, right? So that means there's one real solution. So graphically, what this would mean here, this one is going to cross the x-axis twice. This situation would be somewhere like this up here where it never crosses or touches. And in this case, it would be where it touches but doesn't cross. There's one solution. It crosses or touches at one spot. Does that help kind of visualize what we're talking about there? Any questions on that? Okay, so when you're finding the solutions, you're finding the zeros or where it crosses the x-axis or touches. Okay, so you have a Delta Math assignment, and that is all you're doing today. Okay.